Welcome to Emmelac online tutorial. Now in this question we are told that if xy is the solution of the given equation, 2x raised to the power of log 2 equals 3y raised to the power of log 3, and 3 raised to the power of log x then equals 2 raised to the power of log y. Find x and y. Alright, to start with, let's make this equation 1 and let's make this equation 2. Now to this end, let us apply log to both sides. So here you have log 2x raised to the power of log 2 then equals to log 3y raised to the power of log 3. Okay, and let us recall that according to the law of logarithm, that when we have log a raised to the power of m equals to m log a. Now applying this rule to this above equation here, we have log 2x then equals log 3 then log 3y. Now to this end, also let us recall that when you have log, according to the law of logarithm, when you have log mn, which is a product, this will give you log m plus log n. Now if this is true, then let us apply this rule to the above equation. You can see here we have a product, here we have what? A product. So here we have, now the above equation will now become log 2 then into log 2 plus log x then equals log 3 into log 3 plus log y. Alright, okay, so let us just make these asterisks. Alright, now let us now come back to the second equation. Let us still apply log to both sides of the equation. Here we have log 3 log x then equals log 2 log y. Now still applying the same law here, which is the power law. Then here we have log x log 3 then equals log y log 2. Now to this end, let us divide both sides by log y. Let's divide both sides by log y, and by so doing, log 2 rather, because we tend to look for x. So here we have log 2. Now we eliminate log 2 here, so it means that log y will now be equals to log x log 3 all over log 2, right? Now let us now plug in log y into equation asterisk. So we end up with having log 2 into log 2 plus log x then equals log 3 into log 3 plus our log y now become log x log 3 all over log 2 close bracket. Okay, now let's open the bracket. Log 2 times log 2, we have log 2 all to the power of 2 now plus log 2 log x then equals log 3 all to the power of 2, because log 3 times log 3 will give us log 3 to the power of 2, then plus here we now have log x log 3 to the power of 2 all over log 2. Okay, now let's bring log 3 raised to the power of 2 over to the left hand side and log 2 log s over to the right hand side. Here you have log 2 all to the power of 2 minus log 3 all to the power of 2 then equals log x log 3 all raised to the power of 2 all over log 2, then minus log 2 log x. Okay, oh sorry, this should be log 2 not log x. Okay, so to this end, let's find the LCM of these two equation here. Expression rather. It implies that the whole of this will now become log 2, right? So which will give us log x into log 3 all raised to the power of 2 minus log 2 all raised to the power of 2 log x, and this will give us log 2 raised to the power of 2 minus log 3 raised to the power of what? 2. Okay, and you can see, let us factor out, sorry, this is 2, I don't know why I'm writing x, so let us factor out log x here. So we end up having log 2 all raised to the power of 2 minus log 3 all raised to the power of 2, then equals log x now into log 3 raised to the power of 2 minus log 2 all raised to the power of 2, then all over log 2. Okay, now to this end, let us bring log 2 here. Okay, so let us just multiply both sides by log 2 by multiplying both sides by log 2. So multiplying both sides by log 2, we have log 2 into log 2 raised to the power of 2 minus log 3 raised to the power of 2. Then by multiplying log 2 here, it tends to eliminate log 2 here, so we are left with log x into log 3 all raised to the power of 2 minus log 2 raised to the power of 2. Okay, so to this end, let's divide both sides by log 3 raised to the power of 2 minus log 2 raised to the power of 2. So here we have, okay, so here we have log 3 raised to the power of 2 minus log 2 raised to the power of 2. Okay, then all over log 3 raised to the power of 2 minus log 2 raised to the power of 2. Now the whole of this, we eliminate the numerator, the denominator. So we are left with log x. Now, and when you look at this here, you can see that log 2 base log 2 to the power of 2. Here we have log 2 to the power of 2. Here log 3 to the power of 2, and here we have log 3 to the power of 3. Now, as if now there's a swapping of the numerator, which is the expression of the denominator. Now, for us to eliminate this, it means there's a negative of the numerator, which is that of what denominator. Now, the best way we can approach this is, let us multiply the numerator by a negative value. So here we have, so here we can interchange, we can write the numerator here by saying log 2 all raised to the power of 2 minus, sorry, this will be negative. So here we have, will now become log 3 raised to the power of 2, then minus log 2 raised to the power of 2, then log 2 all over log 3 raised to the power of 2 minus log 2 raised to the power of what? 2, then equals log x. Okay, now by plugging in, by multiplying the numerator by a negative sign, then we end up having the same term, both the numerator and the denominator. Okay, alright, by so doing we can now eliminate. So we are left with negative log 2 equals log x. Okay, to this end, this implies negative 1 log 2 equals log x. Now at this point here, we can now say this is log 2 raised to the power of negative 1 equals log x. Okay, so we can eliminate. So at the end of the day, that x equals to 2 raised to the power of minus 1, or 1 over what? 2. Okay, now to this end, if x equals to 2 raised to the power of minus 1 or half, then what will be the value of of y? So to this end, we have x that equals to half. So let us plug in the value of x in equation 2. Now take note that here or here, that log x equals to negative log 2, right? Now from here we have 3 raised to the power of log x, then equals to 2 raised to the power of log y. Okay, now if log x equals to negative log 2, so we can simply say here this is 3 raised to the power of negative log 2 equals to 2 log y, right? Alright, now take note that this implies that 3 raised to the power of minus 1 into log 2, we are according to the law of indices. Then now a rule in logarithm, if you have a to the power of bc, this can be b raised to the power of log ac. Now let us now apply this rule here. So here we have that y, then it will now be log 2. Okay, and if you can now see that from the right hand side and the left hand side, we have the same base. Okay, alright, so to that end, we can now say 3 raised to the power of minus 1 equals what? Y, which means y equals what? 1 over what? 3. Therefore x equals to 1 over 2 and y equals to 1 over what? 3. Final answer. Alright, if you love what I've just done, kindly subscribe to my YouTube channel and ensure you click on the notification button to be notified of all my videos in physics and mathematics. Thank you and God bless you.